Welcome to Unit 7 about functions. Today we're talking about I can construct a table of values with or without technology. We're going to be looking at examples of functions and then completing a table of values. And the table of values is just a fancy way of saying let's list a bunch of inputs to the function and then show what output you get. And we're going to start off by doing this by hand, in other words, without the use of a calculator, or with minimal use of the calculator. And we're going to start with the function y equals negative 4x. It's problem number 1. Our first input that we'll try is an input of negative 2. And to show what the input looks like, I'm going to show all the steps over here in the table. And I'm going to show that essentially what we're looking for is what does y equal when x is negative 2. And to find that out, I'm going to take the function y equals negative 4x, and I'm going to input negative 2. In other words, substitute negative 2 in place of x. When we do this, we find out that y equals 8. And so for an input of negative 2, the function outputs the value of 8. Similarly, if we input a value of x equals 0, then the output is equal to whatever negative 4 times 0 is, which of course is just 0. And so for an input of 0, we get an output of 0 as well. We'll continue in this manner. For an input of 4, the function yields an output value of negative 16. For an input of 6, the function yields an output value of negative 24. For an input of 8, the function yields an output of negative 32. For an input of 10, the function yields an output of negative 40. And finally, for an input of 12, the function yields an output of negative 48. And so we've completed our table of values. Keep in mind that this is only a subset of the possible input values. We could certainly input numbers smaller than negative 2, and we could certainly input numbers larger than 12. We've just chosen to only focus on those particular inputs. Continuing on, we'll try another function. And again, we'll use limited pieces of technology. You're welcome to go ahead and use your calculator to determine the actual values of the math when you plug the numbers in, if that's something you need to do. I'm doing them in my head, but you're welcome to use your calculator. We're going to try it again with the function y equals x squared minus 5. And again, we've decided to use the numbers from negative 2 to 12, the even numbers from negative 2 to 12. But we could really use any inputs we like to create our table of values. I'm going to show my work again in the same way, and the problems work exactly the same way as they did in number 1. So, for example, we're looking for what is the output when the input is negative 2. So that's just a fancy way of saying find out what y equals when negative 2 is substituted in place of x in the function x squared minus 5. I want you to notice that I put the negative 2 in parentheses so that we make sure we square the entire number negative 2. When we do that, we get positive 4, and then 4 minus 5 is negative 1. And so for an input value of negative 2, this function yields an output value of negative 1. For an input of 0, we substitute 0 in place of x, and we want to know what y equals when 0 is squared and then 5 is subtracted from it. 0 squared is 0, minus 5 is negative 5. And so for an input of 0, this function yields negative 5. I'm going to pause the video for just a moment, fill in the rest of the table, and then you can see the results. So if you'd like to pause here as well, feel free, and we can check our answers together. All right, we're back. We've completed the whole table now. Let's go through the results. So for an input of 4, an output of 11. For an input of 6, an output of 31. For an input of 8, an output of 59. For an input of 10, an output of 95. And for an input of 12, an output of 139. And that completes our table of values for y equals x squared minus 5. Now, doing the math by hand is just one option for completing a table of values. Additionally, our calculators can help us quite a bit. So when we skip down to number 3 and 4, we're going to use our calculator to complete the table of values. This is particularly useful when the input values are kind of high, or perhaps they yield decimals, or something of that nature. So I'm going to pull up the calculator here. The function we're using in question number 3, y equals the square root of x plus 4. So here's your calculator, the graphing calculator. This is just an emulator, so it looks sort of like yours, except of course it's just virtual. And we're going to start off by typing in the actual function into our calculators. To do that, we're going to go to the y equals button on our calculator up here in the upper left-hand corner. This brings up a screen where the calculator is expecting you to type in functions. And our function, once again, is y equals the square root of x plus 4. So under y1, I'm going to type in the square root of x plus 4. Once I've done that, the calculator now has the function in its memory. And if we'd like to see what inputs yield which outputs, in other words, if we'd like to see a complete table of values, all we have to do is go to the table function of our calculator. To do that, we press the second button, and then the graph button, which is in the upper right-hand corner. You'll notice the word table is in blue text. And this brings us to our table of values. The calculator is telling us that for an input of 0, the output is 4. For an input of 1, the output is 5. For an input of 2, the output is 5.4142, and so on and so forth. We can use the arrow keys to scroll up and down through the list to see whatever values we'd like. You'll notice that values smaller than 0 give an error, which means that these particular input values are not allowed for this function. In other words, they're outside of the domain. Once we have the table of values, we can basically just copy the inputs and outputs from our calculator into the table of values on our worksheet. So we're looking for numbers, inputs of 0, 4, 9, 16, 25, 36, and 49. In other words, the perfect square numbers. When I go to my calculator, an input of 0 yields an output of 4, and so I'll copy that into my table of values. Going back to the calculator, an input of 4 yields an output of 6 on this row right here. And so once again, I'll copy an input of 4 yields an output of 6. We'll continue in this manner, scrolling down the table for each value that we need. So an input of 9 yields an output of 7. I'm going to pause the video right here and fill in the rest of the table, and we can check and see if our answers are the same. Okay, so I'm hoping that you got the same values that I did. An input of 9 yields an output of 7. An input of 16 yields an output of 8. An input of 25 yields an output of 9. An input of 36 yields an output of 10. And finally, an input of 49 yields an output of 11. Let's try another using the calculator. Exercise 3 asks us to use the function y equals negative 4x squared plus 6x minus 5. So I'm going to go to my calculator and type that in. Negative 4x squared plus 6x minus 5. Back to the y equals screen. We can clear out the function we just used. And y equals negative 4x squared plus 6x minus 5 is our function. Once I have the function entered into the y equals screen, I press second and the button graph, which brings us to the table, and we can scroll through our table of values to find whatever values we were looking for. So in this example, we're looking for the numbers negative 3, negative 2, negative 1, 0, 1, 2, and 3. I'll do a few together, then I'll pause the video again. An input of negative 3 yields an output of negative 59. An input of negative 2 yields an output of negative 33. An input of negative 1 yields an output of negative 15. All right, stop and do the rest by yourself and then check with me. All right, continuing on, an input of -1 yielded an output of -15. An input of 0 yields an output of -5. An input of 1 yields an output of -3. An input of 2 yields an output of -9. And an input of 3 yields an output of -23. And you'll notice that that matches exactly with what I have in the calculator under the table function. We'll try one more. The function y equals 3 times the absolute value of x minus 1 plus 3. We'll type this in the calculator. I'm going to scoot it over so I can see the function. And the only part that's different here, I guess, is that you need to make sure that you know how to insert the absolute value bars. So I'll go back to the y equals. I'll clear out the function we used in example number 4. And then for example number 5, we have 3 times the absolute value. Okay, so the absolute value is under math. And if we scroll over to num, the first option is ABS, which stands for absolute value. So we'll select that as an option, and notice we get those nice absolute value bars. We want the absolute value of x minus 1 in this problem. And then outside the absolute value, we're adding 3. So now that we have the function inserted into the y1, we can press second and then graph to bring us to our table of values. And then it's just a matter of copying that table of values from the calculator screen to our paper. So an input of -3 yields an output of 15. An input of -2 yields an output of 12. An input of -1 yields an output of 9. And we'll continue in this manner. I'll pause once more so you can try it on your own, and then we'll check together. Okay, so an input of 0 yielded an output of 6. An input of 1 yields an output of 3. An input of 2 yields an output of 6. And an input of 3 yields an output of 9. And once again, that matches exactly with our table in the calculator. The rest you can do on your own, and you can check the answer key provided.